Hey guys, just doing some motor control testing for a client of mine. This is a signal generator. I've got it set at 30 kilohertz, 5-volt signal going into. This is the MOSFET controller. This is the voltage regulator for the gate of the MOSFET controller. I've got 3 motors in parallel. One is a 350 watt. The other is 135 watt, and I'm not sure what this one is. It doesn't have any markings on it, but I imagine it's about at least 50 or so. So we've got just over 500 watts, I guess. I'm guessing at 30 volts as far as power supply, and the scope connected to the scope is actually connected directly to the signal going to the motor. So you'll see the motor signal. Now some of my friends would say this is probably terrifying, but I'll ramp it up here. With the signal generator creating a pulse width modulation, it starts going, the larger motors start going at about 2%. The smallest motor starts in at about 5%. We've got tape on them so you can kind of see them moving. The oscilloscope, this signal here, it's inverted. So this signal here is actually when it's down, the MOSFETs are on. This is the turnoff of the MOSFETs, and I'm not concerned so much about that, but this needs to be as straight up and down as it possibly can. The oscilloscope is on 1 microsecond per division, I believe. No, wrong one, hold on. Yeah, it's on 1 microsecond per division, so it's not even half a microsecond as far as the time that it takes to go from all the way off to all the way on. Now when the MOSFET switches off, this is basically due to the motor, the inertia of the motor. So, and I'm not worried about that because I'm only driving it to turn it on, and then it goes off. Now as I adjust the pulse from the frequency generator, this can ramp up. You can see this is what I'm looking at. This is what I want to stay steady. That keeps the MOSFETs nice and cool to the touch. I can touch those all day long and they're cool to the touch. The motor is actually warmer than the MOSFETs after it's been running a while. But this is at 18%. Okay, ramp that up. That's at about 40%. Signal's still going good on the oscilloscope. 30 volts, pulling about 1 amp. That's at about 50%. That's at about 70%. Pulling about 2 amps. Signal's still looking really well, really good. Everything's cool to the touch. Touching the MOSFETs directly, they feel like they're at room temperature. Go ahead and crank it up some more. So that's at about 90%. You can see on the oscilloscope the other part of the wave is coming in on the back side, so most of the time is spent on. Remember, this is inverted, but this signal right here, that's the one that we want to focus on. That one is very narrow, very short in the amount of time that it takes. That's what's keeping these MOSFETs cool. Like I said, cool to the touch. I can crank it up all the way here. That's at 100%. Scope is flatline because it's all the way on. Motors are running good. They're warm, but they're not hot. Alright, thanks for watching. Ramp it down. Thanks for watching.